Okay, welcome to the blog site and the weekly review for CUME 16. I'm going to start off here with some rounding off to the nearest place value indicated. Note that the example was done on your sheet, and I'm actually going to show you another one here. I'm actually going to do number one. The first thing that you want to do is look at the place value that's being identified in the parentheses. And it tells us for number one that we're going to round to the nearest tenth. So what we should do is first find the place value for tenths, which is your 4. I'm going to underline that. And then what we do is we look to immediately to the tenths neighbor to the right. And that's going to indicate to us whether we're going to round this decimal up or round it down. And by rule, anything that's 5 or higher is going to round up. As we say, 4 or less, let it rest, which means it stays the same. 5 or more, raise the score, which means it rounds up. So this 5 here to the immediate neighbor of the 4 is 5 or greater, so that's going to indicate to us that we're going to round the 0.4 to a 0.5. And you don't need to put any zeros after it, but if you wanted to, you could. But you could just leave it as 5 tenths, and you would be good. Okay, the next section is divisibility rules again. We always need practice with that. And if you don't have a copy of the divisibility rules, I have extras in class. The rule for 2 says that any number that ends in an even number, 0, 2, 4, 6, or 8, is going to be divisible by 2. So starting with 2, we know that 2 will go into 846. So I'm going to write that down. The rule for 3 is you add up all the digits. If 3 can go into it, then 3 will go into the entire number. So 8 plus 4 is 12, and then 12 plus 6 is 18. And I'm going to put this off to the side because you're going to see we're going to need it later. And 3 will go into 18, so 3 will definitely go into 846. Now the rule for 4 is a little tricky, because with 4 we have to look at the last 2 digits and determine whether 4 will go into the last 2 digits, which is not always easy, because if it's a number that you know by heart, like 40 or 32 or 16, then you know that 4 can go into it. But as the numbers get a little bit higher, in this case 46, you might just want to test it if you don't see it right away, to see if 4 will go into 46. And it does not, so you can't include 4. The rule for 5 is pretty easy if it ends in a 5 or a 0, which it does not, so we're not going to put 5 down. The rule for 6 is very simple. If it works for 2 and it works for 3, it will work for 6. So since I have 2 and 3 already listed, I know automatically 6 will work, and I'm going to list it. The rule for 9 is like 3. Once I've added up all my digits, if 9 can go into the sum of the digits, then it will work for the entire number. So 9 definitely goes into 18, so it will work for 846. And then finally, the 10 rule is, very simply, if the number ends in a 0, then it will work for 10. And 846 does not, so we cannot include 10. So we're good for 2, 3, 6, and 9. All right, the example for GCF is actually done on your sheet, but I'm actually going to take you through the process so you can see what I'm doing by breaking down the numbers in prime factorization. Starting with 60, we can start with 2 numbers that, when multiplied together, make 60. Now, you could do 12 and 5, you could do 20 and 3, you could do 10 and 6. I'm going to do 10 and 6. Neither one of these numbers are prime, so I have to break these numbers down further into their prime factors. 10 is broken up into 5 and 2, and both of those are prime, so we're going to circle them. And then my 6 is a product of 3 times 2. Both of those are prime, and then we circle it. Okay, so 60 is done, and now I'm going to do 36. Same thing with 60. It doesn't matter how you start. You could start 12 and 3. You could start 6 and 6. I'm going to start 18 and 2 also. But I'm going to start 6 and 6. And then my two 6s get broken down to the prime factors, 3 and 2 for each. Okay, so that completes my factor trees, and now I'm going to look for common factors. Starting with my tree for 60, I'm going to look at my circled numbers, and I'm going to see what's in common that's circled with my 36. Well, I see a 2 here, and I see a 2 here, so I'm going to cross it out, and I'm going to list it once down here for GCF, followed by a multiplication symbol. And then I have another 2 here, and another 2 here, so I can list that as well. Finally, I've got one more other prime factor, and that's the 3's, which I cross off and I list. Now I've got nothing else that's a prime factor that's in both trees. I have a 5 here and a 3 here, so I can't list any more common factors. Once I have all my common factors together, I multiply them together. 2 times 2 times 3, which is 12. That is my GCF. That's the highest number that will go into 60. It happens to go 5 times. And the highest number that will go into 36. And that happens to go 3 times. And that's how you do GCF. Okay, going on to page 2, part 3. The division problems, which you're going to get the 2 for the price of 1 for this. I'm actually going to do 2 of them for you, so you get a special bonus. Starting off with 3/7 divided by 9/14. There's no need here to change anything from a mixed number to an improper fraction. So we're going to go directly into keep, change, flip. Keep means we keep 3/7 as is. That's 3/7. The change is division to multiplication. And then we're going to flip 9/14 into 14/9. Now here's where I really want you to take advantage of cross-reducing, because it works out really, really well in your favor. If you can see it, we're going to knock it out. Starting with 3 and 9, 3 goes into both. So 3 goes into 3 once, and that same 3 goes into 9 3 times. So I can cross this out and make it a 1 and 3 respectively. But look, you could do it with the other corner also. You have a 7 and a 14. 7 will go into both. So 7 goes into 7 once. 7 goes into 14 twice. And look at that. 1 times 2 is 2. 1 times 3 is 3. 2/3, lock it in, and you're done. That's the beauty about cross-multiplying or cross-reducing, is that it alleviates a lot of the work in the end. So if you can see it, after keep, change, flip, take care of those numbers, knock them out, and it makes things a whole lot easier. All right, let's move on to number 9. Number 9 is like number 8, but we have an extra step in that we've got to change our mixed numbers to improper fractions first. And when you do that, don't try to do it all in one step where you're changing them into improper fractions and doing keep, change, flip in the same step. Take it step by step. So first things first, change them to improper. 1 times 4 is 4, plus 3 is 7. And we keep the numerator or the denominator as a 4. Keep division, division. We're not going to do keep, change, flip yet. 2 times 6 is 12. Plus 5 is 17 over 6. Okay, now we'll do keep, change, flip. Keep this as 7/4. Change division to multiplication. And flip 17/6 to 6 over 17. Now we look for opportunities to cross-reduce. Well, I can't do anything with 7 and 17. They're both prime. And unless one goes into the other, which they don't, we've got to leave them as is. Now, with 4 and 6, remember, one number doesn't need to go into the other. All I need is a common factor for both. So for 4 and 6, 2 will go into both. 2 goes into 4 2 times. And 2 goes into 6 3 times. And now I'm just going to multiply across. 7 times 3 is 21. 2 times 17 is 34. final answer is 21/34. Okay, now in both of these instances, you wound up with answers that were less than 1. Just keep in mind as you continue doing the division problems that if you get a top number that's bigger than the bottom number, then you have an improper fraction, and you've got to change it back into a mixed number before you can circle it. So these two examples that I showed you, although they were freebies on your end, keep in mind that the last two division problems, which I believe are on the next page, may result in a number that's greater than 1. So make sure that you change your improper fraction to a mixed number before you circle it. Okay, so that brings us to our last section, which is a combination of multiple operations with decimals. So I'm not actually going to do this with you. I just want to show you how to set it up. And here's the key thing. I want you to check your work when you're done with a calculator. If you get the answer that it's different from what you have, then you've obviously made a mistake. Go back, take a look and see if you can find it, and rework it. With multiplication, we do not need to line up decimals. We line up digits. So starting with 0.45, which I can put on top, multiplied by 0.07, and it happens by accident that the decimals do line up, but it doesn't necessarily have to. So in other words, if this was just 0.7, you would set it up like this, and that would be the proper way to set it up. But it happens to be 0.07. So in this case, they do line up. Okay? And then just multiply through and make sure you remember that it's important to note in the two products, or the two numbers that you're multiplying by, that we're moving the decimal twice. So when you get down to the bottom answer, you'll have to move your decimal a total of 4 times. Like I said, I don't want to actually do it for you, but double check with your calculator and make sure. So you're going to get point something, and it's going to be 4 digits after you move it over. All right, now with 13, we have a subtraction. So order does matter. So no matter what, 2.53 has to go on top. So unlike multiplication, we have to line up decimals when we add or subtract. So when we line this up, my 0.972 has to line up this way. I'm actually going to do this with you. Add a 0, what we call the annex 0, where we see nothing. And now be careful when you subtract with borrowing. 0 take away 2, you cannot do. Cross out the 3, make it a 2. That 1 that you borrowed is now 10. 10 take away 2 is 8. 2 take away 7, cannot do. Make this a 4 and a 12. 12 take away 7 is 5. 4 take away 9, can't do it. Cross out 2, make it a 1. 14 take away 9 is a 5. Bring my rock straight down. 1 take away 0 is 1. And again, check it with a calculator, be sure, but you should get 1.558. Okay, same thing with 14. Line up decimals. And I'm going to set up the division with you, because it's been a while since we've done it. Remember, that second number is going to go outside the house. So I've got 2.5 out, 3.525 in. Now, if you recall, back when we did this lesson, you can't leave a decimal outside of the house. You have to make this a whole number. So you do that. Technically, we're multiplying both the dividend and the divisor by 10, which is the same as moving the decimal once to the right. Hopefully this is coming back to you. And then my new decimal has to be brought straight up to the roof like this. And now I can proceed with doing my division, long division, like I normally would do. And I'm going to leave that undone, see what you can do with it. But it's important to make sure you move the decimals in the right spot before you start to do any long division. And again, check it with a calculator when you're done. Just don't forget that there are 2 more problems on the very back page, so you should have a total of 17 problems. And that pretty much wraps up QM16 for you. Hopefully this was of help for you. We will do an extra help probably on Thursday at lunch if you still need help. Otherwise, it is due on Friday. Thanks for listening.